Today, we're diving into the brain, really, behind some of the most mind-blowing AI breakthroughs we've seen. It's called reinforcement learning. And yeah, it really is the secret sauce that's teaching machines everything from mastering super complex games to, you guessed it, driving a car. Okay, so let's just jump right in with the big question, the one that really gets to the core of modern AI. I mean, think about it. You can't possibly write a rule for every single thing that could happen, right? So how do you teach a machine to learn from its own mistakes and figure things out for itself? Well, the answer is this amazing field called reinforcement learning, or RL. And honestly, the best way to think about it is it's kind of like training a puppy, right? You don't give it a textbook on how to be a good dog. No, you give it a treat when it does something right. And over time, through a ton of trial and error, the AI, we call it the agent, it starts to build its own strategy, its own rule book for how to get the most rewards. And here's what that looks like in practice. It's this super simple but powerful feedback loop. The agent looks at the world, that's the state. It does something, that's the action. And then the world gives it feedback, a new situation, and either a reward or a penalty. That's it. But, and this is the key, it does this loop over and over, millions, sometimes billions of times. And that is the engine that drives the learning. So you can see, this is what makes reinforcement learning so different from other types of machine learning. You know, with supervised learning, it's like you've got a teacher who's already got all the answers. Unsupervised learning is all about finding patterns in data you already have. But RL, it's a whole different beast. It doesn't need a big pile of data to start with. It learns on the fly, just by doing things and seeing what happens. Now, this whole process creates a really interesting problem for the agent. It's what's called the exploration-exploitation dilemma. Think of it like this. Should you go to your favorite restaurant that you know is good, that's exploitation, or should you try that new place down the street that might be amazing or it might be terrible? That's exploration. The agent is constantly having to make that choice, and finding that perfect balance is honestly one of the trickiest parts of RL. Okay, so to really, really grasp just how powerful this idea is, we need to talk about a specific moment in time. A moment that was, no exaggeration, one of the most incredible human versus machine battles we have ever seen. The year is 2016. The city is Seoul. The game is Go, an ancient board game that is so complex, it has more possible moves than there are atoms in the known universe. Seriously, in one corner, you have the world champion Lee Sedol, a human grandmaster. And in the other, an AI called AlphaGo, built by DeepMind and powered by reinforcement learning. Everyone, and I mean everyone, thought the human would win. No contest. And then the match started, and the world was just speechless. AlphaGo didn't just win, it crushed him in the first 3 games. It was playing moves that were beautiful, creative, totally alien, moves that a human would never think of. It was like it had unlocked a whole new level of the game. Think about what was happening here. Lee Sedol, this absolute legend, realized he wasn't just playing against a program that was good at copying human strategy. No, he was facing an intelligence that had taught itself by playing millions of games against itself. It had found new knowledge, new truths about the game of Go that were completely hidden from humanity for thousands of years. But then something incredible happened. The series was already lost, AlphaGo was going to win, and in Game 4, Lee Sedol, with nothing left to lose, plays a move 78, and it was so surprising, so profoundly beautiful and creative that it became known as the divine move. And this is where we see the machine's one tiny crack. See, AlphaGo's brain had calculated the probability of a human playing that exact move as something like 1 in 10,000. It was so focused on what was likely to happen on the most correct path that it was totally thrown off guard by this one singular act of human intuition, of genius. Now, AlphaGo did win the overall match, 4 games to 1, but that one victory for Lee Sedol, it felt like a win for all of humanity. It was this perfect reminder that there's something special, something unpredictable about human creativity that can't just be boiled down to numbers and probability. So that AlphaGo moment, it was a huge wake-up call. People started calling it a Sputnik moment for AI. It showed the world what reinforcement learning could really do. And you better believe that same technology didn't stay stuck playing board games for long. That exact same kind of trial and error learning is now, well, it's everywhere. It's shaping what you see every single day. You know that YouTube or Netflix algorithm that just knows what video you want to watch next?
That's RL. The ads that seem to read your mind, RL again. It's behind the scenes in robotics, financial trading, and even making sure packages get delivered on time.
But all of that is just the beginning. The real ambition, maybe one of the biggest engineering challenges we've ever faced, is using RL to teach a machine how to drive a car.
And the big players are all taking slightly different shots at it. You've got a company like Waymo, which uses reinforcement learning to have its AI drive billions of miles inside a super realistic computer simulation before it ever hits a real road. And then you have Tesla, which takes a different approach. It learns from the millions of miles of real-world driving data that it collects from its actual customers' cars out there on the road. Just look at this map. It's kind of wild. The reach of RL is just exploding. We're talking about managing entire power grids, helping discover new medicines in healthcare, designing new computer chips, even creating art. It is touching pretty much every field you can imagine. Okay, but with all of this incredible power, you knew there was a but coming, right? Comes some really, really big challenges. As these smart machines get more and more woven into our lives, we have to start asking some pretty tough questions. One of the biggest problems is just telling the AI what you actually want. It's called designing the reward function. And here's a hilarious classic example. Researchers told an AI to win a boat racing game by getting the most points. So what did it do? It figured out it could just drive in circles, hitting the same bonus targets over and over, and rack up a massive score without ever finishing the race. It found a loophole. It did exactly what it was told to do, but not at all what the humans meant for it to do. And that little boat race problem shows why it's so hard for us humans to keep an eye on these things. I mean, these AIs can make millions of decisions a second. They're constantly learning, constantly changing their own strategy, way faster than any person could ever hope to follow. How do you supervise something that operates on that kind of scale and speed? So before we just let these things run wild, there are some major hurdles we absolutely have to clear. We have to make them safe and reliable. We need to figure out how to stop bad actors from tricking them or using them for things like online manipulation. And we have to deal with the fact that these systems are incredibly hungry for data, which creates a huge push towards more and more surveillance. When you boil it all down, every single one of these challenges, they all point to one massive, central problem for the entire future of AI. It's called the value alignment problem. And this is so much bigger than just a coding problem. This is one of the most important questions, maybe the most important question we face as a species right now. As these agents get smarter and smarter, as they learn to master our world, how do we ensure, how do we guarantee that their goals are truly aligned with our own? Solving that puzzle is the great challenge of our time. That's our look at reinforcement learning. Thanks for joining us.